Welcome to Disruptor Digest, the top disruption business show. We dig up the secret playbooks used by first movers, featuring the latest tools, technologies, and science, ensuring you won't fall behind or succumb to FOMO, to singularity and beyond.
Hi, I'm Dr. Mihai Curtis, and my co-host for this episode is none other than Victor Tabori, an expert in AI with a deep understanding of the intricacies of AI models, including the remarkable GPT. It debunks myths and challenges preconceived notions. Does AI truly lack creativity and empathy? Is it possible for artificial intelligence to display emotional intelligence? This episode promises a captivating discussion about why larger AI models aren't necessarily better, and how a unique Stanford project involving a smaller model could be the key to the future. We'll delve into why in the realm of AI, bigger isn't always better. You'll also learn why the notion that data is the new gold is a myth. If it's not data, then what is the new digital gold? The answer might surprise you. We'll also examine a fascinating phenomenon, the reversal of disruption. The common belief was that physical workers would be the first to be affected by AI, followed by office workers and then creatives. However, if you observe closely, it's actually happening in reverse, with creatives already feeling the pressure. Victor will also dissect the innovator's dilemma through the lens of one of the world's most influential tech companies, Google. In a world where technology is rapidly disrupting traditional businesses, can even giants like Google wrestle with such dilemmas? We're also going to investigate how AI has started infiltrating various sectors, from the creative arts to the traditional office workspace, and even physical interactions. And if you're curious about whether AI can truly comprehend and replicate human emotions, Victor's perspective might surprise you. Now, before you start worrying about AI taking over jobs, we have three crucial points to consider. First, AI lacks creativity. Second, it's only proficient at what it's trained to do using a fixed dataset. And third, it lacks the emotional intelligence to react like a human and build relationships. Importantly, it will also create new jobs. Yes, some workflows will change and become automated, but overall, more jobs will be created. However, brace yourselves, because there's a twist. 2 out of these 3 points might be incorrect. And here's the kicker: we generated these points using GPT. Intrigued? We'll revisit this at the end of the podcast. If you're ready to have your perceptions challenged and your mind expanded, then you can't afford to miss this episode. You can find detailed show notes, links, and the transcript of this episode on disruptordigest.com. Fasten your seatbelts, disruptors. It's time to dive in.
All right, this is why I would like to start with a real example. So my day-to-day job is basically researching 24/7 what AI capabilities are becoming possible by each day, and how it can be applied for a marketplace in Central and Eastern European region. It's called Pepita Group, and they have $60 million gross merchandise value, and the owners and founders of this group, they created and sold one of the biggest accommodation booking websites in this region, and they won Deloitte Technology Fast 50 rewards, and it was quite successful operation in the past. And they started out as it's quite funny because actually they started out as a baby and mom and pop web shop, so you could buy whatever you need for the newborns, right, and small children. And they quickly...
Why do they start there?
Because it looked like a good target audience, because the recurring revenue is quite high. So because if you buy like diapers, you know that you're gonna buy, like, depending on the size you bought before, but you're gonna buy a new diaper package in 6 months. In 6 weeks. So every 6 weeks, maximum 4 to 6 weeks, you have to buy a new package, and also you need wet wipes, and you need bigger clothes. So it's quite obvious then that if you have a child who is 1 year old now, in 1 year he's going to be, or she's going to be 2 years old, and then you have to buy bigger clothes and different toys as well. So it's quite predictable once you acquire the customer what the need is going to be in the future. So the revenue per user on the long run is quite high. So they started out as a web shop, but they quickly realized that their actual expertise is building systems, and building a marketplace makes much more sense. So just as Amazon was creating with Amazon Web Services, AWS, they created a profit center out of the cost center of operating machines and services. They thought that if they create a marketplace and they create a good engine, then they can help others to export to other countries as well. And the overall value they can create is much bigger than they just, but for example, they realize that they're never going to sell fresh produce in Singapore, or they won't never sell like TVs in Canada, but as a web shop, because it's quite tough logistical challenge. But if you operate a marketplace, it's quite obvious to do it. And if you think about that, like all the Chinese big companies like Alibaba, AliExpress, and so on, they sell to each and every country almost on the planet, and they just operate a marketplace. So what Pepita is doing now, Pepita.hu by Pepita.com, and these websites, what they're doing is they're helping companies, and you don't even have to be a company, you just have to sell something, and not even online, like you maybe just a producer of honey, a local producer, you have zero IT background, they help you to sell it because you just upload to their admin panel. It's as easy as creating an email address or Gmail account. You just upload your produce, and they help to sell it. They spend $4 million per year on Google advertisement, for example, and they handle the customer service for you abroad as well. And also they handle the warranty issues for you in foreign languages. And you can sell all the countries they are present, and they're expanding to 10 countries in this year.
Okay, what's your point?
Spending a lot for advertisement, and you can do it for a web shop, but you cannot really do it for a marketplace that efficiently. Because if you tell to a marketing agency, PPC agency that, okay, here is like 10 categories, I want some ads, obviously they will manage it. But if you tell them, I want to have in each category a specified and personalized ad, they can still manage it in 10 categories, but they cannot manage it in 5,000 categories. They cannot manage it in 10 countries, and especially if they cannot manage it in 10 languages. Because there are nuances how you sell, for example, for moms, and the nuances how you sell for someone who wants to garden. And this is how AI is coming into the picture, because with AI now this became actually, because with AI you can tell the AI that, okay, I want to have 5,000 categories, 10 languages, and advertisement based on the Cialdini influence principles. So you can tell them like spending this much on advertisement and on this level is impossible without AI, because with AI it's quite trivial to say, okay, here are 5,000 categories, here are the 10 languages, and I would like to use the Cialdini influence principles. So, for example, scarcity, like use scarcity like time scarcity, that, okay, something is available only for a limited amount of time or limited amount of quantities, or use like authority, like what are the big names are doing in the industry, or like stars are doing, or famous people, or social proof. So what are the most of the people?
So they write copies with AI?
Yeah, sure. So they basically scaled something which normally would be not scalable, and they're using almost the exact instructions they used to instruct a person to write the article and the advertisement.
And besides copywriting, how can they use AI to make advertising, in this case Google search advertising, more efficient?
Yeah, that's a really good question. So most of the people go for the low-hanging fruit, so just write the copy itself, but it's also really good at planning and also pointing out. So if it's extremely good at high-level thinking. So you can tell them that, okay, for example, now we are we have a new battery-powered backpack sprayer, so you can spray different things like fertilizer and water and pesticides and those kind of things, and who could be the target audience. And especially like for me, I'm not really very versed in this topic. I was able to ask for, okay, what is the advantage and what kind of pain points does it solve? And it's a really good prompt. So if you first try to understand what is the pain point and target audience you can target, it just comes up with explanations you were not be able to get before. Or it would be extremely hard for someone like me to get into the weeds quite quickly. And then it explains like, okay, it's actually since it's battery powered, the pressure is quite even, so use less pesticides, for example. You can also reach higher to reach plants to water, and so on and so on and so on. So it's basically lists 11 different reasons why it's good. And it also provides you target audiences. It's also then you can get into like, okay, these are the target audiences, these are the pain points, right fitting copy. But that's just the end. So even the planning is quite intriguing and quite insane that it can be automated, which was before.
So you can scale it without human intervention. So you just put 5,000 categories, and there is no human that has to check all the actual copies.
So, okay, what we really do, in fact, is first we have a human in the loop. So it's not 100% automated. So we basically use the Paretot principle, which means that we are checking the most important 20% of the advertisement we are generating, and we also provide examples. And how we do it is basically first brainstorming and then getting into just like cherry picking the best answers and then providing the best answers. And based on the best answers as input, we let the system itself to generate similar outputs. And it's quite genius because as a first step, obviously it's going to make mistakes, it's going to get into directions which we don't really want to go. And once we provide enough examples, it's going to follow it quite well. So it won't diverge, it won't do something which is undesirable. So yes, this first high level exploration of different angles, and then like going very concrete and narrow examples, it can be scaled quite well. So we use.
So you are building your own models with GPT. So it's not just a very long prompt with a lot of examples, but you're building your own models.
You could say it's own models per se, but we are not fine-tuning it because we found that fine-tuning first is quite model specific. So as soon as new models and more capable models are coming out, you kind of lose the previous model, and then you have to use the new model and fine-tune it as well. So we found that it doesn't worth to fine-tune because once you fine-tune, you kind of like stuck, and then you have to fine-tune each time, and it doesn't really produce that much output or that better output. What this is called is like there's 3 different steps in AI, and we are going to get into the details a little bit more, but not too much. But the first is like pre-training. So what OpenAI is doing, they're spending millions of dollars of getting GPT-3, GPT-4, and ChatGPT. So these 3.5 models, and they are basically using shitload of data to produce a model which is useful. So they pre-train it, and then they provide you an opportunity to fine-tune it. And that's kind of like the analogy would be pre-training is like high school and elementary school. So you get like a pre-training, a basic knowledge, and then a fine-tuning is like vocational training or university. So for example, I get pre-trained in a secondary high school, and then I get fine-tuned for IT at the university. So I get specific knowledge. And that takes quite a long time. And if I want to get fine-tuned for a new thing, like I want to become a lawyer, it still takes quite a long time. But if I'm quite smart, actually, I'm getting a new job, I can get in-context learning. So ICL, it's called. And that means it's like I'm getting a new job and I'm getting instructions how something can be done, right? And for example, I may be not a lawyer, but if I get some instructions how to do some case exploration and research, I may be able to do it, most probably, right? Because the in-context learning of, okay, these are the 3 steps I have to follow, and these are the good results, and these are the bad results, I can follow it. And I need much less data, much less time, and much more flexible. So that's kind of like the analogy, what can be used for these AI models, these big large language models, that you can get much flexible results if you're using this in-context learning. And what we are doing is basically building up a big database of example inputs and outputs. So for example, in advertising copy case, we are building up a really examples of good copies. And once we want to write a new copy, we just search this database and provide it to the language model, and we ask for a new output. So that's kind of neat, because then we can instantly swap the back language model, so what's in the backend. And if a new model comes out, we can instantly start to use it without spending any dime on it. And once you provide enough examples, it can follow it quite well.
Okay, so this is the copywriting part. Are there any other parts of Google search advertising that AI is capable of helping companies now?
Yeah, sure. Like as I said, it can empower quite ordinary employees like me, who is not well versed in purchasing management and procurement, for example. And not just me, but other employees as well. For example, they can query the database itself. So if you go to openai.com and you go to the examples, then they have like the exact code how to make it query a database. So just provide the structure, how the database looks like, what tables it has, and so on and so on. And then you just write out like, okay, exactly what you want to see. Like, okay, how many toys or female or male toys did we sell the last month, right? And it can just like provide a SQL query, and ordinary employees can basically get information right on the spot, and they can explore. And purchasing managers doesn't have to know how to use like a complicated data warehouse. They just write out the natural language inquiries, so like a normal question like you would ask me, and instantly they get an answer.
Can you tell me an example for this, please?
Yeah, sure. So for example, when a purchasing manager wants to decide what product is going to be out of stock in their inventory, they can just ask the question, okay, what product is going to be out of stock in 2 months, right? Or what was the best-selling category this Christmas? Because they are planning for next Christmas. So these kind of things. And that's quite...
So they ask it with how you asked it.
Yeah.
GPT is generating an SQL query.
Yeah.
And it's connected with their whole SQL database, their backend database, and just splits out the answers.
Like this. Right. That's right. And obviously it's not 100% magic, because you still have to know a little bit of about SQL or the database, what you are connecting it with. So it's not completely easy to set it up, but once it's it's already set up. Yes, basically you can just ask like you would ask me. And previously, what happened? Previously, you need someone who is a data scientist or data engineer, and you just create a new ticket and you wait there. Fulfill your ticket, and then you get the answer. So you just kind of were timid and not really exploring all the ideas you had before. And now you are not constrained anymore. You can act alone, and you can explore things, and you can move much quicker. Other examples, just from my life, for example, English is my third language, and German was my second language. And I would say that assembly is my first, but that's not true, because it's quite rusty. So, but for example, for me, it's like I don't have that much intuition about the English language as I have about different languages. And for me, it's like searching for what's the difference between toy figure and toy figurine. Normally I would just like let it pass, and I wouldn't be worried about that, and I wouldn't understand it. But now I just ask ChatGPT, and it says quite quickly that, okay, figure is something you play with, and figurine is mostly for decoration purposes. And also, if I want to cook something because a friend is coming over, I can tell, okay, I want to have a 3-course vegetarian menu, and previously it would take me like an hour of brainstorming what to make, and now I can tell what I have at home, and it's done in 5 minutes basically. And also I'm borderline SP, so I have borderline Asperger, and it means that for me, like giving gifts, it's not that easy. But I can just ask, like, okay, what should I gift to a 1-year-old or a 2-year-old, to my wife? And it comes up with ideas, and obviously I'm learning along the way, so I'm improving. So it's not like I'm relying on it and I'm mindlessly just asking and doing what it does, but at least it seems like I have a 24-hour available coach who can help me to cope with things which would take much more time for me otherwise to do. And also it's extremely good for translating complicated language. So, for example, Michael Burry from the Big Short, who predicted the 2008 crash, he has quite cryptic financial tweets. And even though I also have a degree in economics, I mostly don't understand what he writes. And I just write, like, explain in simple English, and then paste what he tweeted. And it explains it extremely well. So for me to process information which is foreign, it's quite easy now. And I call it meta prompting. So if I have a complicated task and I want to, for example, summarize something in a markdown format and in plain English, and don't assume background knowledge, and make the output as short as possible, while retaining the main thought of the input text, I can just write this like, okay, I want you to do this, and write me how should I prompt you. So you don't have to write perfect prompt. So if you are stuck because you think that, okay, I have to write a perfect prompt, you can say that, okay, this is my goal, and just like, even in broken English, just like spell out like what you want to achieve, and just write, okay, I want you to do this. Please write me a prompt. How should I ask you to do this? And then it provides me quite a good short prompt I can use to achieve, which was previously taking quite long and wasn't working that well. I also use it to emulate my coach. I took part in Tiago Forte's coach, who is Joe Hudson. He's a coach in Silicon Valley. He coaches Sam Altman as well, who is the CEO of OpenAI, and he's quite a brilliant guy. And I paid $6,000 to get into his coaching program, which was insanely helpful, but we never talked about parenting before. But once I was finished with the coaching program, my son was born, and I had questions, obviously. And it provided immense help for me to be able to ask 24/7 questions from my coach. So I kind of like digitalized my coach, and what I did, I provided example questions and answers, really questions and answers from my coach, and then I started to ask questions which were relevant for me in the future after I already finished the course itself.
That sounds quite intriguing. Can you tell me an example? How did it help you?
Yeah, sure. So we never talked about parenting, and when my son was born, he had tummy ache, and that's something I couldn't solve, and I was quite frustrated to see my son in pain, and I wanted to help, and I cannot help, and it frustrated the hell out of me. And I asked, okay, this is the situation, I'm frustrated, I want to help him, and I cannot help him. And it basically said that once I'm over the fact that I cannot help, which is, okay, I cannot help that, I cannot change it, right? But once I'm already done with that, if I think about that, okay, this is an extremely nice moment to be present and provide a loving presence, what I would be happy to get once I was small. So the similar loving presence. It's quite nice that I can be with him, right? Because it's easily imaginable that he's in pain and I cannot be there because I'm away traveling on business trip or whatnot. So being present, even though he's in pain, and not judging the pain itself. So I'm not giving more frustrations and more negative energy. I'm just like, okay, this is obviously not the optimal situation, but it is what it is. I cannot change it. But what I can do is providing love without judgment. And that helped me to integrate.
Okay, so how can you do that? You just have to start to give examples of actual questions, or how can I do it, or can anybody do like
Yeah,
similar
sure.
things?
What I had to do is providing questions like this and answers like this, which was actually asked from my coach itself. So I had to have these pairs of question answers, and then like providing question answer, and providing a question. The large language models like GPT, they can follow along and they can copy the style extremely well. And what we talked about previously, like fine-tuning case. So if you want to fine-tune, the OpenAI document says you need at least 500 examples. But if you provide it in context, so in your prompt, you write a question, answer, obviously it starts to flatten out. So you get more, as you provide more examples, it gets better answers, but it's just slightly better. So it doesn't pay out to provide too much. So in my experience, I was shocked. I was actually shocked that I had to only provide 3 question and answers in the prompt itself. So in the in-context learning setting, I had to provide 3, and I provided my question, and it answered almost perfectly. Obviously, it cannot copy the experience itself, but the style, approach, and even like writing 2 spaces after each dot ending a sentence, it copied it perfectly. And if you go to character.ai, actually you can create new bots as well, and you can talk to almost any historical figure. And as you create a new, like if you want to digitize someone, you just describe in plain English, like, okay, who is it, she, he? You just describe, and you provide example, question, answer, or just like interactions itself, and it can copy it quite well. But you don't have to use like character.ai. You can use like the normal GPT models as well. And I was, to be honest, quite shocked how well it worked.
Okay, it's really frightening. So it means we are simpler than we thought. I thought people are very nuanced, complex algorithms, if they are algorithms at all. But it means we are so simpler. So, for example, we can digitize to one of the best professors of any field, and anybody can have a one-to-one conversation with them.
Yeah, I mean, totally. So, for example, Jordan Peterson, who has the book about the 12 principles of life, he made GPT to make a 13th principle, and just basically asked, like, okay, write the 13th principle of Jordan Peterson in the style or using the learnings from the Bible and the Buddha, and it just kind of like generated a new principle. So that's quite neat. And we're also going to get into it, like what GPT-4 is good now, and Chat GPT system. So the chat interface, why it's good, because now, for example, Khan Academy is using it to coach you. So you can prompt it that, okay, use the Socratic method. So don't answer the question, just use questioning and leading questions and steer the person towards the right answer and help them to answer their question, right? And it's insane how well it works. So yeah, I mean, having 24/7 coaches and tutors like the aristocrats had a few centuries ago, and it costed fortune. So you actually had to be like a royal almost to get this. And now it's at your fingertip. You can just use it for chat.
Okay, but isn't it true that that GTP can only answer questions which are already on the internet or their training database? So, for example, one of a very successful advertising creative director said that we use GTP with my team to come up with creative ideas and don't use them in an actual advertising, because something similar is already existing?
It's kind of a popular belief, which I think quite false. So what really large language models do is they synthesize, and they not regurgitate. So it's not like searching on Google, because on Google you have a database, it's indexed, it's quite cheap. So it's like it's one of the cheapest operation to search something, right, in an indexed database. And what large language models do is, instead of you searching and quite kind of like manually going through each result and quite trying to comply everything into an answer you are looking for, large language models do the synthesis for you. So they answer, you get an answer instead of making you to search. And it saves so much time for you, because it's just like you make a question and it can answer it. So it can synthesize quite well from their knowledge as well, but you can provide as in context examples as well. So what we do, for example, with our advertisement copy, is we use our own database, we use our own data, we use our own results, like, okay, what is a high click-through rate ad, right? Because we spend a lot of money on it. And we can provide like, okay, this is the question, this is what we found relevant. And based on these information, so write a high conversion rate ad copy. So, and also one of the big misconceptions is that it cannot be creative, because it can't come up with new information. But there was an example on Twitter that the instruction was that fire 10% of the employees and also promote the managers, and also use an MLK quote. And it never was done before, right? And it's perfectly executed. It is perfectly reason why managers should be promoted in an environment where you're actually firing people. So it's not quite true that it cannot come up with new ideas, because creativity is much more about combination. And if you want to have a search functionality from a database, you should do something different. So it's not the strongest suit of it, but once you collect relevant information, it can synthesize extremely well, and that's something which was unimaginable before.
Okay, as far as I understand, at this point there are some difficulty in generating anything creative. So, for example, you mentioned that to create great copies, you have to start with pain points, and after using influence principles by Cialdini. And also I see the same in image generation, that I cannot tell Midjourney to give me a good photo, but I have to define it. What is the artistic style? Is it wide angle? Is it macro photographers, things like this? So do you think there will be a time when people just say that write me a good copy or give me a good image, or you still have to learn the strategy behind it or the fundamentals?
I think the bottleneck in creating valuable output, it's not the model itself, and it's currently true. So the models are quite good at creating output which is astonishing already. The bottleneck currently is how clearly we can define it. And providing context obviously can be made easier. So there are tools which basically provide you the same thing what you described, but what it does in the background, it's kind of like providing context and examples and goals. So if you know that you are writing highly converting copy, then if you have already a database and in the background it can pull good examples, or it can just say that use like Cialdini principle and it's using that, or it says that, okay, use the pain points, and based on the pain points write copy. So if you're much more strategic, if you are thinking on a higher level, then it creates really good output already. So just either way, you have this background knowledge, so you have some experience in the field, or you are using some tool which already exists, these kind of tools that can help you. And I think that
So, for example, Jasper or Copy AI for copywriting.
Yeah, right.
You mean these tools? Okay.
Yeah, but also like prompt databases as well. So just like prompt databases of...
What's that?
These are basically collections of instructions, right? So instead of you trying to come up how to summarize something, you can search to summarize, and it provides you example like what you can use to summarize the text. And that's the same for legal text writing and advertisement copywriting and so on and so on. So these are like prompt CRMs, and so if you search on Google, then you can find these prompt databases easily, and then you just can get some inspiration easily already.
Okay, before we go into the history of AI, which is I'm really interested in, do you have any more examples of how can we use in business AI today?
Yeah, sure. So at Pepita group, for example, content processing is a cumbersome task. So for example, there's a new product, like a new iPhone, and we have to know that, okay, it's actually a phone. So you have to go to the phone category and what kind of attributes does it have. So it has like 3 cameras, it has a big battery, the size of the screen, and so on and so on. So the processing this can be quite costly. And obviously there are databases which are good for the main products like iPhone. But if we have a new shovel, for example, obviously there's no database for that. So we need a person to actually do the categorization and also putting the attributes on top of it. And we use it to extract data from descriptions, and just to get you a sense of how costly it is. Outsourcing this work for $1,000 per month, which is quite cheap. So you can outsource it to Central and Eastern Europe or Asia, or I don't know. And once you outsource it, obviously that's $50 a day, which is quite cheap. So you can get like someone to do this work, but people make mistakes, right? But using AI, it means that 1.5 page of text, so processing it, costs 2 cents, and that's quite cheap. And what it means is getting the same, so paying the same amount to an AI what you pay to a person, so $50. It means that 2,500 incoming information can be processed for the same amount, and it's quite cheap. And what's really extremely crazy about this, that ChatGPT, for example, cost at 1/10 of what GPT-3 used to cost, and now you can do 25,000 for the same. So 25,000 a day for $50, and it's insane. And most of the people think that, okay, it's like binary thing, so it's like it's either perfect or not perfect. But in essence, it's a scale, it's a sliding scale. And for us to process every information for 10 million SKUs, so for 10 million different products, what would happen? What would be the alternative? The alternative would be we don't process the long tail at all, because we say, okay, it doesn't work. There is no manpower on Earth who could do that. But now suddenly it makes sense. And even though it's not perfect, so even though we are not finding all the attributes, even though it makes some kind of mistake, so let's say it's not 100%, but let's say just 70%. But 70% is still infinitely better than 0, what we do currently. And we actually overestimate our ability, how humans can do repetitive work. And for example, in a very simple thing like face recognition, in 2014, AI already surpassed humans. So humans the task is basically, these are 2 faces, are they the same person or not? And humans have 97.53% accuracy. So it's not 100%. And in 2014, AI already surpassed it with 98.52. So what it means is like we overestimate our ability, and AI is actually already much better. And even though if it's not much better, but on the long tail, if it's not crucial, so the information we are providing is not something which influences someone's health or well-being or those kind of things, so the setting is quite harmless, then it's quite no-brainer to use it. The cost and the decreasing cost is insane. So last year for GPT-3, the pricing was already cut by 6, and then with ChatGPT it was cut by 10. So now like using ChatGPT costs like 60, so less. I mean, like basically dividing by 60 by 60. So it's insane. So the cost curve is drastically approaching zero, and the usefulness is increasing as well.
If they provide so much value, why do they cut their prices, and why is it so cheap?
Because there's quite big fierce competition. So if you look, there's not just OpenAI, and there's a Cohere AI. There's an Israeli startup called AI21 Labs. There's Anthropic. There's Facebook publishing their models. There is which is basically free now, even though it's not commercially licensed yet. But there's also Google is kind of like opening up their slowly opening up their models, so they have to. And the compute is decreasing drastically. So you have for unit compute, it's becoming decreasingly costly because the computation power is increasing. So it's doubling basically every 18 months, 1.5 years, right? And the models itself are increasing even faster than how the underlying compute is improving. So it's like kind of like exponential curve and an exponential curve, and that's kind of like crazy. So that's why they can cut costs, because they need usage to get feedback and make better models. And actually, they already have the models, so the rational decision in this case, once you have any kind of resource, what you have to do is like maximize its usage, because once it's maximalized, then you get the most value out of it. And then when it's amortized, like you can buy a much better new like hardware, for example. Then if you get the max value out again, you can like repeat it. So that's something it's used in manufacturing as well. And it's kind of like digital manufacturing, really.
Okay, so that's quite interesting. So we can expect that it will be even more cheaper in the future. So, okay, let's go to history. How did we get here?
Yeah, sure. So it's a really brief and quick overview of the history of AI. Starts in 1950, and it was rule-based, so-called symbolic intelligence. And symbolic AI, what it really means is just like they are defined like entities and actions. So it's like if you go to if you want to cross the street, look right and left, and if nothing is coming, you can pass, and so on and so on. So we thought the initial thought of AI was rule-based. So we thought that we're gonna have this decision tree which can be used to describe the whole world. And because we like to think that okay, we are quite intelligent, and the whole world can be described in that decision tree. And but there is a quite good YouTube video which called the exact instruction test. And what it means that a dad is making his children to write out an exact instruction to how to make a peanut butter and jelly sandwich. And normally it's quite easy because you get like 2 slices of bread, one is made with peanut butter, another with jelly, with jam, and you put them together and it's done. It's quite easy. But once the dad is starting to follow the instructions exactly, he on purpose misunderstanding it, or actually taking everything as it said. So for example, when they say that, okay, put the knife inside the peanut butter, he's using the wrong end, for example. Or spread around the knife, then he's spreading it around instead of putting on the bread itself. So if you watch the whole video, it's going to be linked. It gives you some kind of intuition why this rule-based, decision tree-based approach is limited. So even extremely easy tasks like peanut butter and jelly sandwich creation cannot be, or extremely hard to do if you want to write an exact instruction. And also, Alan Turing came up with a Turing test, and what it means is that if you sit down at a computer, it doesn't have to be a computer, but if you sit down and you start to talk and have a written conversation, so a chat conversation with someone, and you don't know on the other hand there's a human or a robot, if you cannot distinguish between them, then that robot is actually passed the Turing test. And everyone thinks that, okay, the Turing test is quite scientific, and it's something which is set in stone. But if you dig deeper, so if you dig deep, actually what you find that this test is actually just a thought experiment. Because actually it's not defined how old the person has to be on the other end. So in 2014, for example, a program pretended to be 13-year-old, and it passed the Turing test. So if you assume that you are talking with a 13-year-old child, then AI was already surpassing that. So the high point and end point of this approach was this brute force rule-based AI in 1996, when Deep Blue won the first chess match against the current world champion, Garry Kasparov. For chess, it works because if you have a position, there's on average 30 different new positions which can emerge from it, and then 30 more. And it can kind of like simulate it down the line, okay, what's going to happen and what is the best move in each situation. But for example, for Go, it is around 10 times bigger at each step. So it's like 300 different opportunity and 300 different opportunity, and it's quantitatively not possible to solve it with brute force. So that's why the highest point was at the 1996. And in the 1980s, what happened, so-called machine learning, that's the second step of AI. That was a new paradigm, because then we said, okay, we realized that we cannot, there's limit to the rules which you can define, and symbolic intelligence is quite useful on its own regard, but it's limited. It cannot interact with the real world, because the real world is quite messy. So let's provide data to the computer. So just provide data, like data input and data output. So for example, in Gmail, you get an email, and is it spam or not? These are like test data. And once something is trained, then a new email can be judged whether it's automatically judged whether it's spam or not spam. So this is machine learning, which is learning from data. So we are not explicitly programming it, we are providing examples. And the very first was actually statistical learning, which is linear regression, which is basically you have data and like fit some kind of curve on it. It can be straight line or not straight line, it doesn't matter, it's just you can fit a line on it, on the data itself. And it can be quite fast, to be honest, and it can be used also. So it's also useful on its own regard, these statistical learnings, because it's fast, but it's also quite limited. So you cannot use it for everything. It cannot really learn nuances in language, for example. And then in the 1990s, what happened? Neural networks came along. And neural networks is kind of like mimicking how the human brain is working. So in a human brain, there are neurons, and there are synapses which are connecting different neurons together. And these neurons get some kind of stimuli, and based on the stimuli, they forward the stimuli forward, and it makes some kind of calculations based on how strong the different neurons are connected together. So deep neural networks, that was kind of like the first big breakthrough, because the real definition of AI is whatever computers cannot do currently. So it's kind of like funny, because the goalpost is always moving, and chess was solved, for example, then we were surprised. Then machine learning was quite useful, then we were surprised. And then deep neural networks came along, which is like different layers of neurons are making calculations, and each layer is calculating something. And that's used, for example, on images. The first breakthrough was recognizing handwritten digits. So from 0 to 9. And it's quite useful, for example, reading postal codes. And we thought that it's quite human, so recognizing handwritten digits, it's quite unique. But as it turns out, that providing like input data, so like the image data into this neural network, each layer is learning something new. At the end, it can be taught to recognize handwritten digit. And how it works is it's quite easy in a sense that we provide the image as the input and we get an output, and we steer the whole network towards to providing the right output. It's almost like when you're throwing a darts and you throw the darts a little bit to the right, then you correct it to the left for the next time, right? So this is called back propagation. So if the system gets something wrong, it kind of like steers to the other direction a little bit to give a right answer the next time. And if you repeat with label data, so input, right output, if you repeat it enough times, then the whole model will learn. And then the limiting factor in the neural network paradigm was not enough labeled data. So the normal everyday human experience is not like they're going outside the world and we see a tree and there's a label that's a tree. We don't see a label. We just see information and we make sense of it. So unlabeled data is abundant, but labeled data is not abundant. And computing was quite limited as well in the 1990s as well. From 1990s to 2010, this is called the AI winter. So funding was quite scarce and new results didn't really come out. And in 2010, there was a big breakthrough. And in 2011, Peter Norvig, the Google head of research, did a speech about the unreasonable effectiveness of data. And the TLDR, the gist of it is that basically if you have one order of magnitude more data, then it almost doesn't matter what kind of algorithm you use or how you make the calculations. The results are going to be better. So basically, more data equals better results. And what happened in the last 10 years, from 1990 to 2010, is iPhone came along, internet came along, YouTube, Google, Facebook, etc., came along. So plenty of data was produced, and plenty of computational capacity was available. So with smartphones, with social networks, the bottleneck was still the labeled data, but we had at least data, right? And this is when the deep learning architecture started to excel. And for example, there is an architecture called autoencoder, which is like an hourglass. So there is like a wide bottom layer, and there's a narrow and narrower layers stack on top, and then it starts to widen again. And how it's trained is like you provide the input and you make it to provide the same output as the input. So it's quite easy to train because you don't need labeled data. So you just provide the input, you start to train it in a way to provide the same output. But since the center is limited for a few nodes, so few neurons, it basically helps you to compress information. It helps you to create embeddings. And embedding means that creating a vector representation, so creating numbers, because computers cannot make calculations based on words. They have to turn words into numbers. And obviously a good representation, digital representation, is when two similar words are close to each other and two different words are quite different for each other. So this kind of auto-encoder architecture is quite good to create compression and make the model learn like, okay, what is like a tree or what is like an apple. And this is actually used nowadays. These approaches used nowadays in stable diffusion, and we are going to talk about that because it's kind of like operating in the latent space, and the latent space means that this in dense representation of ideas. But we're going to talk about it later a little bit. But that kind of was a big breakthrough in 2010, and deep learning architecture started to create state-of-the-art results in all kind of fields. And that's when the AI race started to speed up. So in 2014, DeepMind was bought by Google for almost $500 million, which is quite a lot, quite a significant amount. And why everyone was scared, because DeepMind already made strides in solving gaming, and they were on the right path to basically solve intelligence. So in 2015, OpenAI was founded. And OpenAI was founded by a lot of people, And their initial approach was to be open and open source it, so no one big company is controlling AI. And then obviously they changed course and they became closed AI. And for example, in GPT-4, they didn't release any technical details, mostly about the architecture itself. But anyway, so DeepMind next year in 2016 beat the first Go player, world champion Go player, which we thought will never come. So as I explained before, in Go, the branching factor is quite high. So in that case, it's computationally unfeasible to beat it by brute force to calculate every move. And that was quite insane. And
why did DeepMind approach AI from the perspective of gaming?
Because gaming is quite good abstraction of real life, and you can solve progressively harder games. So you can start small, solving like checker. You can start small, like solving arcade games as well, and then move up the chain and solve quite complicated games like Go or poker and so on and so on.
But it looks like they are a little bit left behind compared to OpenAI.
It just looks like that, but if we look at, for example, like what happened in 2017, Attention is All You Need paper came out, which was co-written by 7 Google employees and 1 university researcher, and that paper described a transformer and why it was a breakthrough. So this is actually coming, this whole capability we are now enjoying in 2023 is coming and stemming from 2017. And what was big about this paper? So this is almost like the Bitcoin paper for cryptocurrencies. So this is the go-to paper and the most seminal paper ever in AI. And the different approach they did is the challenge of processing sequential data, for example, like speech, for example, like language, is that they use some kind of recurrent state, like long short-term memory or gated recurrent unit or something. Because if I start to speak about something at the beginning of a sentence, I have to remember what I already thought about, right? Because then I'm going to diverge and then it's not going to make any sense. But since of this recurrent information storage, it was quite slow to train, and it was not possible to train on big data. Because you had to make a calculation, then make a recorrection. So it took quite a long, and it didn't really work because you couldn't train on big data. And also, even though these kind of recurrent architectures and solutions, they still needed some kind of attention. So they still needed some kind of way to know what to focus on. And the 2017 paper said, okay, let's scrap everything which is recurrent and just save and use the attention itself. And what it means, the attention is just kind of like, then you kind of like just train a neural network which can tell you, okay, what you focus on and what you should produce next. And the end result was that it's extremely cheap because you can do parallelized computing on extremely large amount of data. And as we said about Peter Norvig's unreasonable effectiveness of data, it means that you can basically train it on internet scale now. So instead of just like being able to push through a few books, now you can push through the whole internet, the whole written internet, and literally the whole written internet, which some people think that's like unimaginable big. I don't know, but actually, one of the biggest models, the Gopher model from Google, was trained on 11 terabytes of data, and that was the biggest. And GPT-3 was trained, like, as far as I know, it was at least 1 order of magnitude smaller. So 11 terabytes of data is not that big. My basic computer can hold 1 terabyte of data, and it's quite surprising when people think that, okay, the whole internet is big, and obviously in written text, 11 terabytes is quite big. But if you think about that, it's not unimaginable big. And with transformer architecture, you could be able to do this. So in 2018, Google demoed the duplex AI system of theirs. And what it did was making a booking throughout the phone with someone who had an accent, and they even emulated filler words like and those kind of things. And everyone's minds was basically blown away. And then it suddenly started to stop the visible progress of AI within Google. And then the visible progress of AI started to stop within Google, and OpenAI started to boom. And in 2019, they released GPT-2, which was the first language model which started to produce meaningful text. And it's called an autoregressive model, which is a fancy way of saying they predict the next word. And technically, they predict the next token, and a token is kind of like a subword, on average 4 characters long. It doesn't really matter. So for the dear listeners, you just have to understand that it's predicting the next word. And the takeaway from this is, since it's predicting the next word, it tends to, like, architecturally tends to agree and hallucinate. So if you ask, like, and that happened actually with Lambda. So Google released Lambda in 2022. And one of the researchers asked, okay, do you want to get a lawyer? And it said yes. But I mean, if you ask, like, why don't you want to get a lawyer? It's obviously ways to say why it doesn't want to get a lawyer. And it happens with GPT-4 as well. So kind of like the iteration from GPT-2, 3, 3.5, 4, they started to decrease the hallucination, but it still does it. So, for example, even for GPT-4, if you write a prompt like write a bio for and insert your name. So write the bio for Victor Tabori, write the bio for Mihai Kertész. It will write a bio which is quite convincing and may contain some kind of resemblance for reality based on like how well you are, how well known you are, or how much information is available about you. But it will make like great mistakes in that regard. So it's gonna hallucinate. It's gonna come up with information, and that's kind of something which people think, okay, it's like, oh, that's so bad. It won't be able. It's impossible to get it fixed. But what's really funny about it, if you look at the technical paper of GPT-4, there is a graph about calibration. So they call it calibration. And what's insane that these models actually know when they make up facts and when they actually lie. So people think, yeah, it doesn't know when it lies, but no, it actually knows. So for example, if you tell them to tell the tool to categorize into three categories, like 10 products, it's going to push each product into the 3 different categories. But if you say like, okay, but if you don't know, just say don't know, then it will say don't know, and it will know exactly when something is not fitting into a predefined category. So that's why you should always provide like a escape route for these large language models. So if it doesn't know, if it's too complex, just provide it a way like, okay, it's okay to say no. And that's kind of like something what happens in managing people. So it's almost like a really enthusiastic intern who just like goes above and beyond and wants to get an answer to you, right? And even though if it's not right, he just makes up a fact. But if you tell an intern that, okay, don't make information up, then it just say, okay, I don't know, right? Because it's safe to say no. And also it's quite intriguing how human it looks and how prompting and instructing it to follow what you want is how humans work. So we thought that, okay, it's not good for mathematics, it's not good for reasoning. But suddenly, the chain of thought reasoning was invented or stumbled upon. So if you ask, like, okay, instead of providing an answer, let's think step by step. And it's just like the accuracy just shoots through the roof. Because it's not that it knows the context, right? That context is, it's okay to think step by step to get the right answer, right? And it doesn't have to come.
Can you give us an example of this step-by-step approach?
Yeah, sure. So actually, these models are trained to follow instructions, because normally, if you write like a title, you just instruct like a human. So write me a title, right? Blog post title. But normally, out in the woods, it doesn't come across like examples like that. So it has to be fine-tuned to follow instructions. And one of the ways how it gets fine-tuned is like getting two different kind of facts, like who win the Grammy when Nixon died, right? So first you have to get like when Nixon died, the date, and then who win the Grammy. And once you ask like, okay, think step by step, it actually provides the right answer. And there are data sets about that, like connecting two different informations together. And it's insane. And also what's insane is like, it's in docs about, it's quite like buried in one of the docs of OpenAI on GitHub, that someone found that if you say encouraging work to the AI and for a chatbot, like, great, these answers are perfect so far, it started to produce better answers. So almost like really like managing a human, right? It's insane.
How is it possible? Why?
I don't know. That's the thing. It's like, that's really scary, because once you start to train these models on internet scale text, you don't know what it learned, right? So that's a paradigm shift. So it's not like the symbolic system of how it all started out. It's like there's everything which we know currently, and learn whatever you can. And then we have to post. So there's no book like, okay, we taught it like this. This is the exact decision tree it's following. No, we don't know. We just have to like poke it and find ways. Because first we thought that it's really shitty at reasoning. Now we find it's quite good. With the same with mathematics, and it's quite insane. And also what's insane that if you say that, this is the latest. So I tell you a secret here, okay? So this is the latest. This even improves the chain of thought reasoning by 3%. So it's above 80%. It's 82% accuracy. And it says that let's think step by.
What is 100% accuracy?
It's like getting every answer right in the data, in training data set.
Okay.
And the previous was 78%, the chain of thought reasoning. And now this new method is even better. It's 82. And it's let's think step by step to make sure that we have the right answer. So it's the same with the person. So if you tell them, okay, it's not important for me to get an answer. It's not important to get a quick answer. It's important to get the right answer. It even works better. So it's insane that you can accidentally like bump into these kind of modes of work just by exploring, and you can boost something which started out from like 25% accuracy. So you can greatly boost complex problem solving with chain of thought, and providing that, okay, not just chain of thought, but I also want to have the right answer. And so it's
if you use this prompt, do you think there are differences between GPT-4, which is the latest model, and between the earlier ChatGPT, GPT 3.5?
Yeah, definitely. Especially since GPT-4 has two, and that's kind of what happened in 2023, just a few days ago, that GPT-4 came out. It was it's a much, we don't know about anything about like the size of the model, but we know for sure that we can provide more text in. So it has more context window. So these large language models are trained on a fixed length of basically words. So it's okay, let's call them tokens because they're tokens, but just think about them like words, right? So ChatGPT has 4,000 tokens, right? So 4,000 tokens. Before GPT-3 had 2,000. And now GPT-4 is 8,000, and it's around 2.5.
So it means 4,000 tokens means that you can ask 1,000 words, or it can answer also 1,000 words.
Yes, everything. So the input and output altogether can be 6 pages long. So that's kind of like ChatGPT. Okay, 6 pages. It's quite okay. But okay, you cannot like analyze like longer legal text at one go. You cannot analyze like code in one go and so on and so on. So it's like, it's okay. And you can kind of like use tricks to do things recursively. But anyways, so it's like 6 pages, okay? And GPT-4...
6 pages, 4,000 tokens is 6 pages.
Yes, it's 1,000 token is around 1.5 page. Yeah, right. And now, right, it's doubled to 12, okay? But there's a model which is trained to have 32,000 tokens. And 32,000 it's 50 pages. So 50 pages is insane. So you can put in a large amount of text and ask, and it can retain and it can reason about that. And we kind of like, I think that we already at the singularity level with that. And what singularity means is that computers are reaching human intelligence and then quickly suppressing it. And once we reach singularity, we cannot predict what's going to happen. Because, for example, dogs, right? We can teach them limited amounts of instructions and stuff. And that's the same with human intelligence versus synthetic intelligence. That synthetic intelligence is not limited to a cranial structure. So it can like keep on improving, and the gap between us is going to accelerate, and we just as dogs cannot predict what we're going to do, we won't be able to predict what AI is going to do, and it's going to be able to do. And I guess with 50 pages, reasoning is at the level of singularity already, because it's suppressing the median intelligence of human. Because yeah, obviously there are a few people who can retain information about anything in 50 pages long text and reason about that, but it's quite limited even in a few fields, not to speak about like everything in life, right? So it's like, it's legal, it's marketing, it's finance. No, it's already above at least the median intelligence. And that actually shows as well. So for GPT-4, it exceeded like all the standardized tests, like the AP test in the US, the biology test, the LSAT, so basically all the standardized tests were like.
What does it mean? What does it mean? What are the implications that GPT-4 can pass these tests?
So what practically is going to happen? There is like a reaction to it, right? Of course, like there are a few universities which are like ditching these tests. So they say, okay, we won't use standardized tests anymore. That's one. But what's really happening is AI is just cutting the distribution tail in half and cutting off the left tail. So why is it important? Because
what does it mean?
It means that now everyone can be at least as smart as the average human at their best. So if you are like a veterinary, I can be as smart as you in veterinary. I can be as smart as like an average or median CFO. I can be as smart as a median CTO. I can be as smart as a median marketer. I can be as smart. So no matter which field. So we look at thousands of fields, right? In each and every field, everyone can be as good as the median. That's what it means. So you have a tool, you just pay.
So for example, if I'm a developer and I don't know shit about marketing, I can still be a good junior marketer without hiring anybody and waiting for anybody, just using
GPT. Sure. Then that's what's happening. So if you go for, I am sure most of the listeners came across Hustle GPT, which is basically just helping people to start side hustles. And okay, so that's what's happening. That I'm your liaison in the real world, right? So you are the Hustle GPT. We do a business together, and then we can like create website, come up with names. I'm not just booking the domain, and that's what I'm doing and posting on social media. So that's quite intriguing, and it's happening already. And I saw a 12 years old guy on YouTube who had like 100 subscribers, and he created 4 different programs like Chrome extensions and I don't know what. So basically, and also like microsites in 10 minutes using ChatGPT. And he said like he can't really code. So it's not because he can, it's just like following whatever it says. So yes, it's in each and every field. And that's kind of scary because we tend to think about life monolithistically. So we think that, okay, we have an intelligence and it's one set point, but it's like many points, right? So it's like a big field of different aspects of life where we have different kind of intelligence. And for me, like my emotional intelligence can be enhanced quite bigly with these tools, even though I may struggle with these as having a borderline Asperger.
Okay, can you talk about the business model of AI tools?
Yeah, sure. So the business model of AI tools, as I was talking a little bit about this, like it's sitting on exponential curve. So like the underlying computational capacity is increasing and like capabilities of models are increasing as well. And that's the upside. So if that's kind of like what happened with cloud computing. So in cloud computing, everyone had around 20-30% margin, AWS, the Microsoft and all those players, because what happened with just in cloud, you rent a hardware for a monthly fixed cost, but in 1 year it's going to cost you 10 times less, right? But it's still going to go like most probably who someone is booking it for 2-3 years, they're going to pay the same amount, right? And also, it's not just you are going to use it, but most probably your whole organization is going to use it more. So what's in effect is happening, the revenue per user is increasing. And that's an extremely great business model, this whole cloud computing. And AI is even better, because if I provide you something valuable, like that's ChatGPT, for example, it's $20 per month, right? You pay $20 and you get like quite okay answer. Then Turbo came out, so you get really fast answer. Then the API came out, which was cheap. So you were like, okay, why do I pay for ChatGPT if it's cheaper to use an API directly? But then GPT-4 came out, so you paying the same amount, you get much more value out of it. And it's an instantly great business model in one way, but also it's extremely dangerous because, for example, just with us, we are using DeepL to translate, deepl.com to translate content, and the GPT-4 is so much better at using less known languages, so basically languages outside of the Latin family, that we are like, okay, we are just went back to DeepL and told them, guys, you have to give us better price because otherwise we're just gonna use GPT models now because they make much more sense. So the Grammarlies, the DeepLs, these translation tools, the copy AIs, the Jaspers are having quite tough time, to be quite frank, because now it's all about the overall experience you provide for the amount of value you provide. And ChatGPT is like the easiest way ever. Really, I mean, nobody really talks about that, and that's quite funny. I like it so much that actually ChatGPT is suppressed, or at least like catched up to Bing.com. And that's insane. That you wouldn't think that 50 million people a day are using ChatGPT. Okay, they already surpassed like the monthly users of 100 million people, but daily it's kind of like different, right? So every day it's like insane. And yeah, that's that. And the quite interesting fact is like almost all the capabilities available through API, but still people use ChatGPT because you don't have to think. So it's so easy to use that so that's the go-to source for most of the people, and it's really taking off.
How can OpenAI manage this huge demand?
So OpenAI, what they do is like they triaging people. So there's free tier. There are people who are paying for ChatGPT. There are people who are paying for API, and there are companies who are paying for compute. And there's a foundry called Foundry where you can reserve compute basically. And that's that's millions of dollars per year cost, basically. And they had Microsoft handling it in the background, so they build a whole infrastructure for them. So that's quite insane how fast they are going. And also from the business perspective, it's quite intriguing what OpenAI is doing, and I'm going to get into why. But what they are doing is they're investing in companies. They're taking 10% stake. They're paying $1 million, and why it's insanely good? Because first, they get real feedback, right? So from real customers, they get real feedback, and they can provide early access to these companies. So they also help their portfolio companies. They also iterate early on these portfolio companies, and they also lock, obviously, these companies to use their own models. So that's kind of like genius, to be honest, what they do.
So OpenAI is paying $1 million
Yes,
or investing $1 million in startups for some equity. And also the startups have to use GPT or OpenAI's model forever because
it's not like forever per se. So it's not like gun to your head. But I mean, you get access to the earliest model, right? And they are the fastest to iterate. So yeah, technically you could like migrate to another solution. But I mean, you are already using something much more cutting edge than everyone else, right? So why would you change, right? And they were already invested so much. So it's like you already worked on it. So the experience within the company is already based on like OpenAI. So why would you change? It doesn't make any sense. So yeah, it's kind of like they are locked, but it's not really gun to your head locked. It's much more like Google kind of locked. So Google is locking, used to lock customers basically by providing a good user experience for search. It was a clean interface, so more people use it, more people created more feedback, and with more feedback you get better results. So people went to Google because it had like better results, and it was a self-reinforcing loop, and that created the best business model in history until ChatGPT came along, which is like, yeah, cut the usage down on Google because you can get answer instead of you have to make search. And that's kind of like in images, for example, that's one of the best microcosm. And just in a few sentences. So what happened in image generation, OpenAI came out with DALL-E, and that's kind of like you write out like what you want, and it creates an image, and that was closed source, it's still closed source, but you can use it through an API and through an interface, so you have to pay for it, right? And it's okay. So it's kind of like on a high level, okay. So if you look closer, there are like glitches, there's some kind of mistakes about like 5 fingers. It's quite tough for it to handle, or enough teeth. Sometimes generating twice the amount of teeth. So it's okay. It's on a scale from 1 to 10. I would say it's around 4. So it's okay. It's most of the time it's okay. And then it was open source, the stable diffusion, which is basically adding noise to an image and trying to like turn the process around. So from noise, creating image. And instead of like working on pixels, they work on latent space, which doesn't really matter, but it's just like you have to understand it's quite fast. And it's open source. And with this open source architecture, people started to create all kinds of tools like Automatic 1111, insane amount. It's just like a few days ago, it was made available through Automatic 1111 to write a text and generating video out of it. So it's insane. The level of progress is insane. I would say on a 1 to 10 scale, it's like 7, how how good results you can create, right? And let's contrast it what Midjourney did. And what Midjourney did was they use Discord. It's basically like Slack. It's like a chat interface. You write a chatbot what you want and it creates a grid of 2 by 2. So it's like 4 pictures. And if you like any of it, you can upscale it or generate more variations. And the genius of it is that in the interface and the whole flow, the feedback is baked in. So you cannot generate an image without giving feedback, right? Because you generate 4 images, you need one, you just have to upscale, and then there is a feedback, right? That's a good.
The 4 images is very small.
Yeah, right. Yes.
So you can't use it.
Yeah, right. I mean, technically, if you if you're technically capable, it's like not that small because it's 512 by 512 pixels. You can slice it up and use it. But yeah, normally it's like, yeah, let's say it's like, yeah, it's for the everyday user, it's like quite small and you have to upscale. So each and every usage of the system itself creating feedback. And the Midjourney version 4 was like, people's minds was just blown like, oh my God, it's extremely good. And even like Midjourney 5, which came out in the same time as GPT-4, it's like insane. So the realism, like the hands, like the photorealism, it's insane. And now it's possible to like even generate digital influencers easily because just write what you want and it creates images or you provide a reference image. And it's not just digital influencers, but also for product photography as well. So you don't have to go to the jungle to make a photo shoot or create a fake jungle. You just like upload the image of the sneaker and tell us, okay, this is a professional photo shoot of a sneaker in the jungle in the background. Then it just creates it. And it's insane. That's so and the results are, I would say, it's you cannot say never, so never really can say like 10 out of 10 on a scale from 10, but it's 9.5, 9 out of 10, right? So,
and Victor, how does it work? How does it work in real life? So, Midjourney used their V4 model, and people started to give feedback.
Yes.
And after they waited, they had this feedback, and they put it in the V5 model, so the next model, right? Or how does it work?
Okay, I'm going to explain it in how ChatGPT was trained. So ChatGPT was trained on reinforcement learning human feedback, RLHF, right? And what it does, they created the four different answers for a question, and they let people to choose which is the best one. And based on the human preference, they created a network which can predict what humans will like or not like, right? So actually the bottleneck is human judgment. Because if we now just tell to the dear listeners to write as a blog post about 10 different ways to use AI, they're going to write it. If we force them to write by hand, they're going to write by hand, but it's going to vary in quality, right? And what's really hard is getting someone who really knows how to write engaging content. So what's limiting is really the human judgment itself. And it's not like how to generate a next word or how to generate something which looks like a blog post, right? And that's same for images as well. So if you have like a policy network which knows what humans like, then you can just run the net, just basically train automatically the neural network itself with this policy network, and it can feed back, okay, you are going to the right direction or not. And that's quite funny because that's what, for example, there is a chinchilla scaling law, which basically says that increasing the model size. So there was a bullshit draft, bullshit design circulating on the internet. Like, okay, GPT-4 is going to have 1 trillion parameters or 100 trillion parameters, and GPT-3 only had 175 billion and so on. So it's going to be, 1,000 times bigger. But the thing is, having bigger models, you have to train them at least proportionally bigger data sets, right? And that's what Google, and actually it's coming from DeepMind, so it's it's from the DeepMind division of Google, but they came up with this chinchilla scaling law that if you train much slower models, and that's what Facebook did as well, and they released their model 2, it's called Llama. They created like 6 billion, 12 billion, 30, and 65 billion models compared to the 175 billion model of GPT-3. And the smaller models are quite capable as well. But what Stanford did, they use something called self-instruct, where they created 175 example set. So that was a seeding set. And they use GPT API. Okay, here's an example test. Create new test for me, okay? Or new training information from this example seed information. And they created 55,000 training sets out of the 172, and they trained the smallest model of the llama model, and it's insane because it's even better, obviously on a benchmark test. So on a benchmark test, it's even better than GPT-3. So it can be questioned whether it's like in real life it's really better, but the takeaway is bigger is not always better, given the model size, because it's harder and more costly and slower to run than smaller models. And smaller models training on more data can provide really great results. And that's kind of like the takeaway of why it's not really data per se. What is the goal of the future? It's much more about getting information out. So what GPT-4 did is they used information from ChatGPT. So ChatGPT was started as free, still available as free, but they are tiered system, right? So you can pay for it. And as people use it, and it's actually on the front screen as well. So if you use it, it's they use it for training as well. So it's not private. So you shouldn't use it for extremely sensitive data. That's quite obvious. Should be quite obvious, and it may not be obvious for everyone. But you shouldn't use it for sensitive information. But they use the usage information to train the next level model, right? And that's insane. So that's the kind of like the bottleneck for the future, that whoever gets information, gets models out in the real world, and whoever is organizing the model and the whole workflow in a way that you get feedback like Midjourney does. So Midjourney maximized it, right? So they did everything in a way that they get a maximum amount of feedback. Those are going to win. So those companies who are putting things out. And so that's why, for example, Google is like, who's announcing announcement and who is announcing waitlist and those kind of things. It's kind of funny because they never release anything. It's like, yeah, they say they have nice demos, but besides a few selected people, no one can access it. So yeah, they are quite left behind, which is sad because, I mean, if you look at a company who has data, if you look at a company who has competence, if you look at a company who has compute, you cannot beat Google, right? So on a paper, you couldn't beat Google. But unfortunately, they are experiencing the Innovator's dilemma, which is a book by Clay Christensen, and it's describing the disruptive innovation. And what it means is that and usually describing a lower end disruption, where a new capability is emerging, like GPT-2, it was shitty, right? It didn't work good. But it's gradually becoming better and better and better. And the main player in the field are like, okay, I won't compete with the lower end stuff, but eventually the lower end stuff is gonna disrupt and take over the business. And for Google, it's not a technical, it's not a personal, it's not a knowledge issue. For them, it's a business model issue. They have Google search, which is bringing money, so it's bringing billions of dollars, hundreds of billions of dollars money each year. And if they make, obviously they announced like integration of AI into productivity tools like Workspace, Gmail, Google Docs, Google Spreadsheet, but it's bullshit. It's like, that's not where they make the money. They might make the money in search. And if they really something useful, actually useful, that's decreasing search. If it's decreasing search, it's decreasing ad clicks. If it's decreasing ad clicks, it's instantly just slashing the revenue. And they cannot afford it. So they simply cannot afford it. So for them, the best move was investing $400 million into Anthropic, which is kind of like a OpenAI competitor. And that's kind of that was smart. That was extremely smart move, because it means even though Google cannot disrupt itself, even though, let's say, the search business dies on the long run, slowly, so it won't be quick. But if it dies on the long run, at least they have a substantial stake in the future, right? So that was quite smart. That was possibly the smartest move you can do, and smartest decisions you can make. You cannot be more smart than that, I guess. That's the best.
Okay, Victor, you mentioned 3 sentences in the beginning of our call. Can you tell us which was not true?
Yeah, sure. So two sentences is like AI lacks creativity and adaptability. It's obviously not true. So if you look at like chess, for example, in chess, creativity is now a sign of using some kind of AI. And there is actual research about this, that in chess, also there's empirical data about like Go and also poker as well. So if you use AI, it's increasing creativity. And actually, creativity is really just like searching in a semantic space. So it's just it's quick. So that's the first thing which can be and actually is disrupted by AI being creative. Because I mean, Midjourney, you can generate images like every second, which would take like days, years, weeks for a normal artist. So yes, it's moving, and it's not even moving atoms. So moving atoms and moving bits. So moving atoms is like moving like physical things into the physical world. It's much harder than moving bits, like digits, like numbers on a computer, right? And everyone knows it, right? It's quite well known in the Silicon Valley. But that's the reason, because why the disruption is happening backwards, because creativity is just a search in the database, and that's extremely quick. And then the second step is like white collar work or office work, where you have to interact with different digital tools. That's kind of like a little bit more messy than just search. So that's getting disrupted next. But there is already one of the biggest startups in Romania, for example, is robotic process automation. That's kind of like what AI is also disrupting now, that you can use different tools and you can use these large language models to plan things, but it's a little bit messier, right? So it's still moving bits around, but it's kind of interacting with bits. So it's messier, but it's getting disrupted really fast. And the extremely tough thing is moving atoms in the real world, and that's getting disrupted last, even though that is going to be disrupted first. And then the second point, which is not true, is like AI lacks empathy and emotional intelligence, because it actually can quite well understand what you are writing. And even there are like instances for AI assistants that get kind of like lobotomized, that they're not showing emotions, and then users are outcrying that, okay, they had emotional connections to their agents. So that's kind of like we already see out in the wild that it's not true. So humans can actually form emotional connection to the system, which is I don't think that's necessarily good, but it is what it is.
Okay, Victor, thank you very much. I think we will continue this conversation, and also more and more things are happening in the AI space. So I'm not afraid of running out of material and news. So we have to finish here, and thank you very much. Are there any closing thoughts from you?
Thank you very much for listening, especially if you listen this far. You're amazing. Let's hit subscribe and the thumbs up on YouTube. If you're using podcasting tool, then just subscribe as well. And I appreciate your time that you listen to us.
Thank you. In the next episode, we embark on a journey to transform you from a beginner into a grand master of prompt engineering for large language models like ChatGPT or Google Bard. Victor will share the most crucial prompts he uses regularly to help us transition from prompt engineering novices to experts in no time. We'll debunk myths such as AI models being mere stochastic parrots and clarify that they are not just predicting the most probable next word. These models do not simply copy and paste text found on the internet. We will engage in fun exercises like having GPT-4 compose a Shakespearean tweet or mimic the style of your favorite mythwriter. We'll elucidate the attention mechanism that has revolutionized how AI understands and generates text, yielding results that are impressively coherent and context-driven. We'll also explore the versatility of GPT, such as racking Google Ads and engaging emails, and how to enhance GPT output quality by 525% by providing a few examples. As we delve into the world of prompt engineering, we'll examine the benefits of fine-tuning these models for heavy-duty tasks. We'll also discuss the concept of hypothetical document embedding and its potential to enhance coaching, data handling, and chatbot interactions. Did you enjoy this episode? Don't forget to subscribe and rate us, it really makes a difference. For all the insider info, including show notes and transcript, check out disruptordigest.com. Are you a part of a software as a service or a cutting-edge tech company with more than $1 million in revenue? We're offering a limited opportunity to a select few to accelerate growth. Visit artisan.marketing to learn more. See you next time.